Our next presenter shares his name with one of the famous members of the Kelly gang, but he's not here to take your money. He's here to talk to you about electrical safety. Joe Byrne is an inspector with WorkSafe construction team and a licensed electrician. He completed his training in the Pilbara and then spent more 25 years on the tools. And he joined WorkSafe following an electrical incident and injuries to a workmate. He's got 5 kids, so I think we need to give him a round of applause for that. But he's going to come and talk to us about electrical safety. Thanks, Joe.
I think it's my wife that deserves the round of applause, to be honest. But anyway, yeah, thanks for having me here, guys. It's an honour to be here. I just jumped at the opportunity to get away from the big smoke, especially during the school holidays. This venue as well, what a beautiful place, you know. I feel like I should have a guitar slung over my shoulder, but I actually heard this morning that it's haunted, or there's a ghost here. So, Sally, is there anything in the regs about paranormal hazards? Maybe that's next. I am, yes, a qualified electrician and have worked all over Australia and Europe for 25 years plus in mining to residential, and I joined WorkSafe 5 years ago, shortly after a dangerous incident involving electricity that resulted in serious burns to my workmate. In that time, just reiterating what Sally said earlier, is WorkSafe's here to support industry by administering, enforcing and promoting the work health and safety laws. And as such, here we are today. Andrew mentioned I share the same name as Joe Byrne, Ned Kelly's partner in crime. I'm not here to rob you. I'm here to provide some information. I've heard it said that common sense doesn't exist anymore, but I disagree. Especially in the farming community, I would say that the hardest thing about having common sense is dealing with people that don't have any. Okay, let's get into it. Is it the green one? Green? Yep. Okay. Electrical safety. Firstly, establish good farm safety practices. It's the law. If farming is your business, you're a farmer who has workers on your farm, you're what's referred to in the legislation as a PCBU. I've never really liked that term. I always feel like a robot. PCBU. Anyway. It means that you're a person conducting a business or undertaking, and that means you are subject to the requirements of the work health and safety laws. We here in WA have now harmonised with the rest of Australia, except Victoria, who always like to be a little bit different. We invented the AFL. So they're under OSH laws. They have OSH laws. The new work health and safety laws came into effect in 2022, which you're all aware of by now. And one of the biggest changes from the old to the new laws is the penalties. For breaches of the law that result or contribute to the serious injury or death to someone at your workplace, depending on your role in your business, you could be charged with industrial manslaughter. That's got a maximum penalty of 20 years in jail and a $10 million fine. I'm not saying this to scare you, it's just to reiterate the importance of establishing good farm safety practices. The work health and safety regulations state that a PCBU must manage risks to health and safety associated with electrical risks at your workplace in accordance with Part 3.1. Part 3.1 are your general duties. Your general duties are identifying hazards, managing the risks using the hierarchy of control, and maintaining and reviewing those controls as necessary. A common term used in the world of safety is risk assessment. I hear it a lot. Assessing risk is something that we do every day, whether it's walking down some stairs or reversing a car or putting some shopping in the back of your car. You're assessing what could go wrong if you did it wrong. And unfortunately with electricity, it's something that you won't see, hear or smell, but you will feel it. And by then it's probably too late. You could end up dead very easily, and that's the risk associated with electricity. The power that's used to supply your home, your lights and appliances, and equipment, etc., funnily enough, is called low voltage. Low voltage is between 50 volts and 1,000 volts AC. And death by electrocution is most common in voltages greater than 100 volts AC. Our home outlets, as you probably are aware of, are 240 volts. Some of you might have farm equipment that runs off 415 volts. And there have been fatalities with voltages below 50 volts. So factors like your own body's natural resistance and at what stage the compression of your heart was at the time of the shock can be the difference between life and death. Also, you could be on a ladder trying to change a dodgy light bulb and receive a boot and fall and break your neck. Don't try and fix an electrical issue yourself. Get a qualified electrical worker to do it. Use your instincts, use common sense, and contact your local Sparky or LGers, WorkSafe Building and Energy, or your network provider, Western Power. I'm not sure what it is up here. Is it Western Power? Or Horizon? Let's take a run through some of the things you can do to minimize the likelihood of someone being injured by electricity at your workplace. Identify unsafe electrical equipment. You must ensure that electrical equipment is regularly inspected and tested by a competent person. Firstly, a competent person regarding electrical equipment is someone who's qualified, certified, for example, an electrician. As far as regularly, there has been guidance that's been put out, and it generally follows a 3-month, 6-month, 12-month rule of thumb. Electrical equipment that's used in an environment in which the operating conditions are likely to result in damage or a reduced lifespan. So environments that include moisture, heat, vibration, mechanical damage, corrosive chemicals, etc., could result in damage that allows dust or moisture into the internal electrical components. And obviously these are environments that would typically require more regular testing. A visual inspection you can do yourself, and you should do prior to use. Any suspect items should be immediately put out of use, tagged, and either isolated or kept in a safe place until they're repaired or discarded. If we have a look at the slide there, you can see the cable there they've tried to temporarily fix it with danger tape. Danger tape obviously doesn't provide the same level of protection. It's there's only a couple of millimeters of tape between you and electric shock. The top plug there, that's very common, where the extension cord has just been pulled that many times that the inner cores are showing at the plug top. Once again, it doesn't have the same. It's not double insulated. It doesn't have the same level of protection there. I think that one of those shows a plug with the earth pin file down. This is probably pretty common. I've seen it. I've come across it a lot where the portable welders, oh look, the earth pin's fatter. I know what to do. I'll just cut it down with a grinder and file it back. You can't do this. It's designed for that reason, and that's to allow for bigger fault currents. The other two pictures, that's spaghetti junction, but it could also very easily start a fire, or a heater, So you might want to have the fire brigade on your favorites on your phone. Next, RCDs, residual current devices. Everyone in this room by now should know what an RCD is. If not, where have you been for the last 15 years? In your electrical switchboard, you should have both circuit breakers and RCDs. A circuit breaker or a fuse protects the cable whereas RCDs are designed to protect you. RCDs will, when properly installed and maintained, provide high levels of personal protection from electric shock. You must ensure that any electrical risk associated with the supply of electricity to plug-in electrical equipment, such as anything that plugs into a socket outlet, is minimized by the use of an appropriate RCD. RCDs need testing, which you can do yourself. You do this by operating the test button on the front. Different brands will have different test buttons, so familiarize yourself with them. Some of them can be a little bit hard to find. I believe Building and Energy have put out some information recently and an animation about testing of your RCDs, which I think states it should be done every three monthly. You don't want to be testing your RCDs when the footy's on either, especially during a derby. Go Freo. I thought I had that in. Anyway. With both electrical equipment and RCDs, you must keep records of the testing until it's next tested or removed from use. Switchboards. Electrical switchboards do require maintenance. Keeping them clean can not only ensure they function correctly, but also keeps them safe. They should have a lid or a door that's lockable, and inside the escutcheon covers and panels should be secured properly so that there's no gaps where a finger could fit in. This will stop any inadvertent contact with the live wires inside and stops dust, dirt, and moisture ingress, potentially affecting the functionality of the components inside. Plus, it also stops mice and vermin and other little critters causing damage. You'd be surprised the amount of call-outs I've had where we've no power, I've got out there, I've opened up the switchboard cover, and lo and behold, it's fried mice or crispy gecko. Keep the switchboard access clear. Obviously, in case of emergency, you'll need it. Make sure everything on your switchboard is labelled correctly. You don't want to be fumbling around switching things on and off in the case of an emergency. On the right-hand side there, you'll see an older type of meter panel, switchboard box with the black background. The wiring rule actually prohibits electrical workers from using semi-enclosed rewirable fuses to replace semi-enclosed rewirable fuses, meaning that type of porcelain fuse cartridge is slowly being phased out, and electrical workers must replace the fuse with a circuit breaker in these instances. The panels that the fuses are mounted on are often asbestos, and we're all aware of the dangers of asbestos. Building and Energy have published a fact sheet that provides guidance on switchboard panel repair work and asbestos safety. Portable generators and batteries, inverters. If you're using a portable Jenny to supply a transportable shed or a tool, transportable demountable or a tool shed, you'll need to modify that generator, and in some instances, and they do this by removing what's known as the MEN link. When you do that, then the generator's not fit. It's unsuitable for use anywhere else. Be mindful of that. With the push in renewable energies, inverters and batteries are becoming more commonplace throughout regional WA. It's because they're easy to install, they're quiet, and they require little maintenance, but they also have hidden dangers. Lower voltages, but much higher current. The available fault current in a regular battery energy storage system can exceed 20,000 amps. And that's the equivalent of dropping a spanner across the terminals of 200 car batteries joined together. Bang. Therefore, they must be installed in a suitable location, not like the one in this image. Although that aesthetically looks good, it's not robust enough. to protect from mechanical damage. Much of the farm machinery on your properties doesn't have great parking capabilities, so backing into an unprotected or poorly protected battery system could be catastrophic. And you've probably all seen footage of trying to put those fires out as well. It's nearly impossible. Plus the fumes are very toxic. Power poles. You must ensure that a worker or any plant or material used or controlled by a worker on your farm does not enter what's called in the regulations as the danger zone of an overhead electric line. General rule of thumb for that is 1 metre for low voltage, 3 metres for high voltage, and 6 metres for transmission power lines, which is 33 kVA. Check for overhead power lines before starting work. If you don't know the voltages, find out. Contact your network provider. It's the same for the underground utility cabling. There is information available like Before You Dig Australia and apps like Look Up and Live available on the internet that can assist. Western Power also have an online network mapping capacity tool. To reduce the chances of incidences with overhead power lines, you can consider using plant and machinery that is unable to reach the danger zone. You could move the plant or structures permanently away from overhead power lines. You could erect a physical barrier and signage to prevent plant, equipment, or a person entering the danger zone. You can also contact your network operator to energize or isolate the overhead line for the duration of the work, or to permanently relocate the overhead line away from your work area. If you're unfortunate enough to be operating farm machinery and you make contact with an overhead power line, stay put in your cab if possible and call for help. If you do need to get out of the machine, don't just step down. Get to the lowest point of the machine and land with your feet and jump from there and jump with your feet to land together on the ground. Then you've got to bunny hop away until you're at least 8 meters away. The machine is conducting the electricity into the ground, and the field, where it enters the ground, the field gets weaker the further away you are. There's a thing called step potential, which is where one foot is in a higher charged area and the other foot is at a lower charged area. Your body will become a circuit, a path for the electricity to flow, and as you can imagine, this doesn't end well. Be aware also in these situations that there's a chance that the machine's tires could explode, even hours after, without warning. It's called pyrolysis. So stay well clear of the machine for at least 24 hours. In one of the previous farm forums, an inspector from Building and Energy provided information regarding the responsibilities of power poles. This is an area that's regulated by Building and Energy, but as a quick recap, the network operator is responsible for their cable and assets up to where it makes its first connection to your property's electrical equipment or wires. So a power pole on your property, unless it's part of the network, is a private power pole and your responsibility, regardless of who put it there in the first place. If you have any concerns regarding the condition of the power poles or even the sag in the line on your property, call the network provider and they'll quickly let you know if you can do anything, or if you need to get an electrical contractor to check first. Whatever you do, do not get your tape measure and hold it up to the power lines to see how high they are. Okay, a recap. Provide and maintain a safe work environment. Be proactive. There's so much information that's out there at the moment online. I would suggest even subscribing to the Building and Energy and WorkSafe newsletters. There's codes of practices. This is all free information that's available online. Inspect and test regularly and keep records of those tests. As far as dodgy equipment, if in doubt, turf it out. And check the location of overhead and underground power lines before you start work, or before work starts. I'm sure all your farmers are very familiar with the land that you're working on, but often this familiarity can lead you to stop noticing the hazards around you. You must notify WorkSafe immediately of an electric shock arising out of the conduct of your business or undertaking occurring. And lastly, no DIYs when it comes to electrical work. Thank you.
Thank you, Joe. Any quick questions from the floor? One quick one.
Most farm cows only 480 or 240. It's not 450.
Oh, is it 480, is it? Yeah.
480s, 2 places.
2 phases. Yeah, okay. Yeah. Well, there you go. You just said 415. Yeah, okay. That's interesting. All right. Thanks.
Terrific. Thank you very much, Joe.
Thank you.